Hi Tactigon crew! Topic of this video is the user environment interaction that must be absolutely easy and simple in order to create a satisfying user experience. The interaction with the device couldn't have been possible if the general purpose input-output or simply GPIO ports didn't exist. Every processor and microcontroller have a set number of GPIO ports to which the user can connect, and they have some electronic parts like buttons, sensors and many more. It happens many times that the device itself has to communicate information to the user in a simpler way than a complicated log files. In this case, LEDs are the way to go. Color-coded diagnostic codes are easy to understand and a more cost-effective way to implement debug options. The Tactigon board, with its built-in multicolor LED and GPIO ports, is provided with everything you need to develop your next project. Let's see together now how it's done.
First of all, go to the Tool window and check if Next Board, USB Serial and Tactigon are selected. Then choose the right COM port. In this example sketch, we're going to cycle the red, green and blue color of the onboard LED based on how many times we press a button connected to the Tactigon board. Now we're going to include the Tactigon I/O and Tactigon LED libraries. Those libraries contain all the necessary functions that we're going to need. We will be declaring the RLED, GLED and BLED handlers, and also the GPP1 through GPP4 handlers. The first are used to manage the onboard LEDs, and the seconds are used to initialize GPIO ports. Then some variables are declared to keep track of the button state and the LED color cycle. In the setup function, we're going to initialize the LED with their names and turn all of them on. The GPIO ports are also initialized. GPIO 1 and 2 as outputs and GPIO 3 and 4 as inputs. The button is connected to the GPIO 4 pin. In the main loop, the state of the button is read by the GPP4.read function. If the button is pressed, the state is low, and vice versa if released. The first if statement will increase the counter if the button is pressed. The second one will change the color of the LEDs when the button is released, according to the count value. Then the state of the button is memorized in a variable for future use. Once we've uploaded our code to the Tactigon board, we can verify its functionality. You may now unplug the USB cable that we use to power and upload our sketch. As you can see, we have mounted a button that is connected to the GPIO 4 pin, the one that will read the state in our code. As you can see, the board produces a white light. This is due to the fact that we have previously defined that all R, G and B LEDs will be turned on once the board is powered. If we now press the button, as you can see, the LED will cycle through the red, green and blue light. Once all three colors are represented, the LED will turn completely off. So our code works correctly.